Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about the power of foundation models. This episode is based on a tech blog titled FM Intent, Predicting User Session Intent with Hierarchical Multitask Learning, written by the Netflix Data Science and Machine Learning team. You can find their link in this episode's description. Throughout this episode, we will explore this topic from both the business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Netflix is one of the world's largest streaming platforms. It serves hundreds of millions of members across more than 190 countries. Its core product looks simple on the surface: help users find and enjoy content. But under the hood, it is an extremely complex personalization system. At any given moment, Netflix needs to decide what roles to show, which titles to highlight, and what artwork to display, and even which trailers to autoplay. One of the key challenges Netflix faces is that not all user sessions are the same. A user opening Netflix might be in very different moods. Sometimes, they know exactly what they want and just want to press play as quickly as possible. Other times, they are browsing casually, looking for inspiration. In some sessions, they may be searching for a specific title or actor. In others, they might simply be checking what's new. From a business perspective, understanding session intent as early as possible is critical. If Netflix can accurately infer what a user is trying to do within the first few interactions, it can adapt the experience in real time, prioritizing search, surfacing more relevant recommendations, or reducing friction between the user and the content they want to watch. Over time, those small moments add up and directly affect engagement, retention, and ultimately their revenue. So the motivation here is clear. Predict session intent early, accurately, and at a massive level, and use that signal to drive better personalization across the product. Now we understood the business problem to solve, let's shift gear and dive into the technical side to see how the team tackled this challenge. At a high level, Netflix's goal is to predict user session intent. This work builds on an important foundation Netflix had already put in place. Prior to this work, the team developed a foundation model-based recommendation architecture, which can learn rich, general-purpose representations of user preferences. Instead of training many narrowly scoped models for different recommendation tasks, this foundation model serves as a shared backbone that captures long-term user taste, their content attributes, and the interaction patterns across the platform. The power of this approach is that it dramatically improves user-level understanding and can be reused across multiple downstream problems. While the foundation model excels at capturing who a user is in general, session intent is inherently more dynamic and context-dependent, which is shaped by recent interactions, timing, and situational factors. This is where the new model FM Intent comes in. The team enhanced the existing foundation model using hierarchical multitasking learning. This allowed the system to first predict a user's latent session intent, and then use that intent as a guiding signal for next item recommendations. Unlike conventional approaches where intent prediction and recommendation are loosely connected or trained independently, this FM Intent approach introduces a clear hierarchy. Intent is predicted first, and those predictions directly inform what content should be recommended next. This results in a more coherent and aligned recommendation pipeline. To understand how this works in practice, it helps to look at what user intent actually means in the Netflix ecosystem. User intent isn't explicitly labeled. Instead, it shows up through a wide range of implicit interaction signals. Those include what actions user takes, how they navigate the interface, and what types of content they engage with. For example, intent can be reflected in action types, such as whether a user is trying to discover new content or continue watching a previously started title. It can also appear in genre preferences, like a shift from light comedies to crime drama, or in content format preferences, such as whether the user is looking for a movie versus a TV series. The FM intent learns to infer these different facets of intent by modeling patterns across interaction metadata, rather than relying on any single signal. Architecturally, from the technical perspective, the FM intent consists of three major components working together. The first step is input feature sequence formation. Each user interaction within a session is transformed into a rich feature representation that combines categorical embeddings with numerical features like timing information. These features are then assembled into a sequence that captures how the session unfolds over time. This creates a detailed behavior timeline for the model to learn from. Next step comes the user intent prediction component. This sequence of interaction features is now fed into a transformer encoder, which is particularly well suited for modeling sequential data. Through a multi-headed attention, the transformer captures both short-term signals, like the most recent clicks, and the long-term patterns that spans the entire session. This model generates predictions for multiple intent-related tasks in parallel, with each task corresponding to a different aspect of session intent. One key innovation here is how these intent predictions are aggregated. Instead of treating each intent independently, the system uses an attention-based mechanism to combine them into a single compact intent embedding. This embedding reflects the relative importance of different intent signals for each session, making the model both more expressive and more interpretable. Finally, the system moves to the next item prediction, where hierarchical multitask learnings play a central role. The predicted intent embedding is combined with the original input features and passed into the recommendation component. This intent prediction is not just an auxiliary task. It directly feeds into the recommendation task as an input. This hierarchical setup ensures that recommendations are explicitly conditioned on what the model believes the user is trying to do in the moment. As a result, the recommended items are more closely aligned with the user's immediate goals, whether that means quickly resuming a show or exploring something new. With all the systems setting up, the team evaluated it using both quantitative and qualitative methods. On the quantitative side, offline experiments show consistent improvements across several key metrics, indicating that the model performed better at predicting intent and improving next item recommendations. Beyond the metrics part looking at the qualitative side, the team also conducted clustering analysis on the learned intent embeddings. These analyses revealed meaningful and interpretable groupings of user sessions, providing qualitative evidences that the model was capturing real behavior patterns rather than just noises. Together, these validation results show that this new system not only performs better on paper, but also leads to a more intuitive and effective personalization system in practice. Now we've discussed both the business problem and the technical solution, let's wrap it up. In this episode, we explored how Netflix tackles the challenge of predicting user session intent by expanding the power of its foundation model with the hierarchical multitask learning architecture. This approach helps Netflix better understand what users want in the moment and personalize the experience in real time. Ultimately, this leads to improvements in its recommendation system at scale. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.